Good morning, everybody. Today is the 21st of December, Monday. Um, Getting back with another video and looking at what we're going to work on this week, short week before Christmas. Just wanted to take a moment, students. I wanted to make sure everybody looked at Friday. So if I go into my course here, last Friday would have been December the 18th. And there was a video posted there called Mechanical Advantage Extra Credit. If you didn't take a look at that, I've already received a few submissions from students who received the extra credit, but I hope you did see that that was there. Remember, you should be checking daily in these folders and watching the videos and completing the assignments as they're posted. Um, Today we're going to start with the red folder here, week 9. And of course, today is Monday. And there will be a video posted in here, but I'm making that video right now, so it's not there yet when I open the folder. But what you will see in there is a PDF file, Mechanical Advantage Notes and Problems. And you're going to want to put that into Notability. We're going to work on that there today. I'm going to have you complete that, and that is going to be an assignment that needs to be completed. Okay, so let's take a look. I already have my Notability, and I already moved that file there. There it is at the top of the list, Mechanical Advantage Notes/Problems. I'm going to open that up. So if you don't remember what mechanical advantage means, please go back and rewatch the video from the 16th of December, which would have been last Wednesday, where I did an entire video explaining and teaching about what mechanical advantage is. Of course, there's also information found in your textbook in Chapter 8. So if you'd like to go there and review what mechanical advantage is, that might be a good idea too. So here's a basic idea that I think we've covered several times, but under the context of mechanical advantage, why do I use a machine, right? Because machines can do two things. Okay, machines can multiply forces, can multiply a force and make you have more strength than you would have on your own. And the other thing is machines can change the direction of a force. And that is a useful thing as well. I can push down on a lever and the lever is going to push up on the object that I'm doing the work on. And in a lot of situations, that is very useful. Okay, so those are the two things. By doing those two things, what we do is we say using a machine gives us a mechanical advantage. Okay, it allows us using a mechanism, using a tool, to be able to do something we would not be able to do on our own. Okay, so what is the definition of mechanical advantage? Well, MA, mechanical advantage, is a number that tells us how many times a machine multiplies a force. Okay, it's a number that tells us how many times a machine multiplies a force. So if I say this machine has a mechanical advantage of 2, basically what that means is that the machine doubles the force. If I have a machine that has a mechanical advantage of 3, that means the machine triples the force, right? All it is a number. It's kind of a multiplying factor. It has a formula. Okay, mechanical advantage, MA. Let me write it out here first. Mechanical advantage is equal to the output force of the machine divided by the input force of the machine. All right, and if I want to abbreviate all this and write it in terms that are a little simpler, I can say MA equals OF over IF. Ma equals of over if. Okay, the output force of the machine divided by the input force. Okay, so if I use a machine and I know what force was put out by the machine and what force I put in, I can calculate my mechanical advantage. Okay, this formula right here actually gives us what's called the actual mechanical advantage, right? It's the measured mechanical advantage that we get when we use a machine. Okay, now if you think about the specific types of simple machines, levers, pulleys, wheel and axle, incline plane, screws and wedges, they all create a mechanical advantage, but each one does so in a little bit of a different fashion. And so each of those machines have their own formula to calculate mechanical advantage. Now, the calculation of these are going to be what's called our ideal mechanical advantage, right? They are not going to take into consideration the factor of friction. So these are going to be what is supposed to happen without friction. They're useful formulas that we can use to calculate the mechanical advantage. We're going to go through a couple of the simple machine types. So let's start with a lever. Okay, I'm going to draw. Okay, here's my fulcrum. Remember, that's what the pivot point on a lever is called, is the fulcrum. Okay, here's what I call my effort, and here's my resistance, let's say, right? So down here, the resistance is the object I'm trying to lift. So on a lever, the distance from where the effort force is being applied to the fulcrum is called the effort arm of the lever. Okay. And the distance from the fulcrum to where the resistance is called, and I'm not going to fit this all in here, is called the resistance arm of the lever. Okay. The mechanical advantage of a lever is determined by the ratio between those two arms. How long is the effort arm compared to how long is the resistance arm? So the longer and longer I make the effort arm, and the shorter and shorter the resistance arm, the mechanical advantage is going to increase. So the MA of a lever, MA, and I'm going to put in parentheses lever, is calculated by taking the length, and I'm going to write the whole thing out here, of the effort arm and I'm going to divide that by the length of the resistance arm of the lever. Now, that could get confusing sometimes when you see a second class lever. And let me show you this real quick. I'm going to erase this just because I don't have any other space to write in. Okay, if you put that down on your notes, that's fine. Just leave that there. Um, if I have a lever and the fulcrum's at the end, I don't know if you remember what a second class lever looks like, right? But let's say I'm lifting an object. It's kind of like a wheelbarrow, right? This would be the wheel down here where the fulcrum is. I'm lifting the load here, which is my resistance, and I'm applying my effort out here. Okay, now the confusing thing here is where is the effort arm and where is the resistance arm? Well, the effort arm is still the length of the distance from the fulcrum to where the effort is applied, right? So here's my effort arm, EA, is that total length. Where's my resistance arm? Well, my resistance arm actually goes from where the resistance is to the fulcrum. So on a second class lever like this, the two arms actually overlap. Okay, wherever the effort is to the fulcrum is the effort arm. Wherever the resistance is to the fulcrum is the resistance arm. So there is a problem you're going to see a little bit later on where you're going to have to do that. So just look back and hopefully remember how that goes if you see a second or a third class lever. So anyhow, that's the formula, the ideal mechanical advantage of a lever, the length of the effort arm divided by the length of the resistance arm. Let's talk about an inclined plane. Okay, an inclined plane is a ramp, something that goes at an angle, okay, and raises an object up a certain height. Now, think about a ramp. What's easier to walk up, a gradual sloped ramp or a steep ramp, right? And I think most of you would probably agree that the gradual slope of the ramp. So basically, an inclined plane, its mechanical advantage is created by its slope. Okay, and the slope of the line is going to be, whoops, just erase my inclined plane. Let's put it back. Is going to be determined by taking the length of the plane, distance from here all the way down to here, and then the height of the plane. So the mechanical advantage, MA, of an inclined plane is equal to the length divided by the height. Okay, pretty simple formula. All right, let's move on. A wheel and axle. So wheel and axle, if you remember correctly, and I wish I was a better sketch artist, but let's just say that you have a large round object like this, and then you have it connected to and turning along with a smaller round object, right? This large part is called the wheel, and this smaller part is called the axle. Okay, think about this. This is kind of like, I mean, it's your steering wheel in a car. Obviously, that one kind of sticks out. You could think about wheels on a car that just roll, although those aren't really creating a mechanical advantage. This is also like a screwdriver. Say if I'm using a screwdriver to turn a screw. If this is the end of the screwdriver and I'm looking down on it, here might be like my Phillips head screwdriver. Okay, why does a screwdriver allow me to turn a screw and push it in the wood? It's because the wheel part of the screwdriver is fatter than the shaft of the screwdriver. If you were to try to grab that shaft, the axle part of the screwdriver, and turn the screw using just that skinny part, you would find that you would not be able to turn the screw. But because the screwdriver has the fat handle on it, when you put your hand on it and turn it, that wheel and axle system gives you a mechanical advantage. Okay, and the bigger I make the wheel compared to the size of the axle, the more of the mechanical advantage that I have. Okay, bigger wheels, smaller axles. So, the mechanical advantage of a wheel and axle system is calculated by dividing the radius of the wheel, the big circle. Now remember, the radius is the distance from the outside of the wheel to the center, right? 1/2 the diameter. And that's going to be divided by the radius of the axle. Radius of the wheel, radius of the axle. That's what tells me the mechanical advantage of a wheel and axle system. Sometimes the whole wheel doesn't have to be visible either. Sometimes wheel and axles don't look like wheel and axles. If you think of a crank handle on like a pencil sharpener or something like that, it doesn't look like a wheel, but when you turn it, it goes around in a big circle, right? So therefore it functions as a wheel. Anyhow, as you get a little more experience with those things, maybe that'll be a little clearer, excuse me. All right, final type of simple machine we're going to work with today. We're not going to do screws and wedges, although there are formulas for their mechanical advantage as well. But we're going to talk a little bit about pulleys. Pulleys are a little bit of a special situation. Um, in order to calculate the mechanical advantage of a pulley system, you're going to count the number of rope segments between pulleys. Between pulleys and the load, right, which is the object being lifted. Okay, so you're going to count the number of rope segments between pulleys and the load. And as we go, and I'll do this next sheet with you a little bit and show you some of these, um, that might make a little more sense. All right, so we're going to look at the next now. These are problems concerning mechanical advantage. You notice we have, for number 1, we have a lever. Number 2, we have an incline plane. Number 3, we have a lever. Number 4, we have a pulley system. Number 5, an incline plane. Number 6, although it's hooked together by a belt, okay, we have a wheel and axle system taking place where one large circular object turns another and they turn in tandem. Gears and things like that on bicycles, gears in car transmissions function on wheel and axle systems. Sometimes the gears are meshed together with, teeth in the gear that hooks up with the teeth on the other gear when they're like right next to each other and they turn together. And sometimes they're hooked together with a belt or a cable of some sort, like in this picture, but they still function that. And we have some pulley systems here. So, what I'm going to have you guys do is you're going to go back and look at the formulas for each of the simple machines, and you're going to calculate out the mechanical advantage. Write out your numbers, MA equals, and show me how you're going to set it up. Show me the work. and then you're going to write your MA, your mechanical advantage for each of these machines based on the formula that you used. Okay. Now, with the pulley systems, remember, a pulley system is calculated by counting the number of rope segments between pulleys and the load, right? So what that means is I count these rope segments because this is going from the load right here, load up to the pulley. Now this rope segment over here, I don't count. It's going from the pulley to like the effort, wherever the person would pull on it. So this one does not count to calculate the mechanical advantage. Only the ones from the load to the pulley or between pulleys. So if you look at some of these other pulley systems here, which ones do I count? Well, let's look at number 8 here. This segment here goes from pulley to pulley, so I count it. This segment here goes from pulley to pulley, so I count it. This segment here goes from pulley to pulley, so I count it. This one goes from pulley to effort, so I don't. Right? Only the rope segments between pulleys and the load are counted to find the mechanical advantage of a pulley system. Okay? So, you can try those on your own. They're all very simple math. Go back and look at the formulas we just took on the other page and calculate it out. And I'd like to see an answer that looks like, MA equals, show me the work you did. Now, on the pulley systems, there really isn't any work. You're just counting rope segments. So you don't have to necessarily show me a calculation for the pulley system. It would just say something like, MA equals, and then I would put my MA down. Remember, MA doesn't have any units. It's just a number that tells me how many times the machine multiplies a force. Okay, after that, you've got this crossword puzzle. Okay, these are all things that we have talked about and covered in the last couple of weeks. You can look in your book, chapter 8, look at some of the vocabulary words. Go back and look at through some of the notes and stuff on notability that we took on mechanical efficiency, on work and power, on all that kind of stuff to find the answers for this. Okay, but I'd like you to fill this out and complete this crossword puzzle. So you have these easy mechanical advantage problems to do, and you have this force and work crossword puzzle. Okay, that is an assignment, and you will see it listed as Mechanical Advantage Notes/Problems, the same title as the PDF in Schoology. And when you complete that, please upload to the assignment. Okay, thank you. Have a great day. Let me know if you have any problems.